This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Seberg. Good morning, Robert. Good morning, afternoon, evening to you, dear listener, to our final episode of the year.
Peter. It is the last episode of the year and I am very, very tired. I arrived yesterday from Vancouver and it was a crazy week at NeurIPS.
Tell us, you just returned from Vancouver, actually, right? You're in the middle of your jet lag.
Yeah, I'm in the middle of my jet lag. There were over 16,000 people from around the world, and you cannot just walk through the poster sessions and get inspired because there are so many people, so many posters, so many topics. Yeah. Whoa.
I want to come to the posters later. Yeah, I looked at them, but there's a couple of other things. What was your personal highlight after what? Is it a week? A week, I guess?
A week. My personal highlight, I met Max Welling, outstanding European researcher and such a nice person. We will record an episode and he will talk about his new company. It's called CASP AI. And then I met Fei Li, also very nice person.
Not too fast. Max is from Amsterdam, right?
Yes, he's from University of Amsterdam and raised 30 million euros. His idea is to use AI to design novel materials.
That's great, good. Fei Li, yeah. Fei Li was, I think she was, at least she replied. And she replied, it must have been, when did we start? 5-6 years ago. I think it was episode number 3, 4, or 5. We were still recording in German, and it must have been on the topic of the ImageNet, yeah. And she actually replied to it. That was nice at that time.
And yeah, everybody at NeurIPS is so open-minded. You can ask anyone questions. They're open to your topics. They are interested in your topics. That totally surprised me. There are no fears of contact between the stars and the participants. Sepp Hochreiter had the keynote at NeurIPS and talked about he called it 3 phases of AI. And the end of the lesson, more in the main part then. But Fei Li and Ilya also had the same topic in a way. The whole community is running out of fuel and they mean data. That was a big topic. Yeah. I have a quote from Ilya. I foresaw everything in AI the past decade, assembled colossal models, and now standing on that Mount Olympus of predictions, I have precisely zero idea what comes next.
Ilya is kind of the last,
the superstars, yeah,
but the last superstar to leave OpenAI,
yeah,
right,
yeah,
okay,
yeah.
So he was one of the co-founders, and
yeah, exactly.
Out of a range of people, he was which was about a couple of months back. So we're already talking back. What happened in 24? But that sounds almost like, is he saying that he doesn't know where things are going, or
everyone asks the same question: what's next? Some say physics and AI. Sepp prefers to talk about industrial AI, and we need new methods and new approaches in AI. Yeah.
Are we going to listen today to the interview you did with Sepp on live LinkedIn, or?
Yeah. We did an interview at 7 in the morning. It was very early. The whole community has to set itself new goals, I would call it, and is looking for new ideas.
So I actually was able to experience SAP Keynote online. So if you allow me, well, you're going to go to the Q&A later on.
Yeah,
But
yeah.
maybe if you allow me, I'll spend half a minute, maybe just sharing these topics. You mentioned the words already, if you want to.
SAP describes three phases of AI: basic research, scaling the big models, and industrialization. And we now have to adapt these models for robot, drones, embedded applications, right?
Are we going to be able to share some of his main foil? But this one amazing foil. I don't know where he's got it from. I mean, there is a reference here. There's according to Gu X, Coren, some other people, factories. I don't know if they came up with the base idea on which basis he built. Research is always building on the shoulders of the other great folks, and then you are the next great person in line. But it's very interesting. It's a chart which starts the basic development, as you just said, and everybody doing their thing. So there's a huge variety. And then at some point in time, so the chart moves to the left. It's a very interesting chart. And then what happens is people start to scale up on the models, on the parameters. The big example then, of course, is Transformer. So it's almost like, and then everybody does Transformer, it moves up. And then Zeb says the next phase, industrialization. So you come back again in the model and parameter size, right? And then again, the individualization starts, which for Zeb is then about industry.
Safety, security. And then you have domain-specific requirements when it comes to the industrialization of the models. And then you have to ask yourself, how do you adapt the models? And Sepp's opinion is that we have to think about how to solve this, and that scaling is not enough now.
Very good. And then I believe later on, because I did look at you are not live. I didn't know it was happening. 7 o'clock in the morning. It would have been okay for me actually during the day. I didn't know what was happening. And you're going to be talking later about you're asking him, and then Zeb's close is kind of the end of the bitter lesson now.
Exactly.
We talked about the bitter lesson a couple of months back. For those of you that didn't hear it at that time, but the bitter lesson is a quote from Sutton. Rich Sutton is the person kind of inventor of reinforcement learning. That's what he's been for me. He has written the book on reinforcement learning, and he was saying that's 5 years ago. And basically he's saying, whatever we humans have come out with, if we look back at 70 years of AI research, it has always been CPU. That's the exact quote, but I try to just, the way I understand it, it is like we humans in our brains, we do something, and then there's the next generation of processors, NVIDIA in the past, it was Intel, now it's AMD, NVIDIA, and a couple of other ones. And then there's a new processor, and it completely moves away all the research, right? Now, Zeb is saying we have now come to the end of the bitter lesson, right?
Yeah, we need to find new methods, right?
Right. So what he's saying, if I then finish kind of in my wording, okay, Rich has been correct for the last 5 years. CPU was the only number one big thing. But Sap is saying now we need the human brain again, right, to come up with new ideas. And he says, no, we have a chance. We have an opportunity for the human brain to come up with these ideas. So
I want to come back to the topic of data, because then there was an interesting opinion, and there is still a lot of new data hidden in the field of life sciences. Maybe this is the next big thing, but perhaps also in our domain, so the industrial AI domain. Yeah.
Yeah. I mean, the question is about, what is hidden, what is not hidden. And I mean, what is very interesting, we maybe do a couple of looking back into this, what we want to do anyway today, also looking back over the year. And, the one thing that I come to mind is that hasn't been solved. If this is this complete copyright, we have New York Times and everybody, the complete world of copy owners, huge companies, individuals, artists, people that work with content, text, writers, everybody against, not everybody, but let's say that's a black and white, against those bad, big tech companies that have stolen all of our work. That's one story, right? And then there's, of course, many different visions. One is that is correct, and the other one that is not correct, because the algorithm does, in principle, nothing else than what humans have been doing over thousands of years. We've learned from what has happened in the past, from an artistic perspective, and we move art history further into the future. But the point is,
But you are now talking about language models, right?
our language, but also visionary, of course, graphics, the same, yeah.
Okay, yeah.
No, but it's the same. No, it just came to my brain to say, I have not heard a single no, I have heard only one. There was a German, like an organization was gathering, and but I believe because they were some kind of an organization and not a company, there was a judge that said, now they are fine. Not sure if you recall which I'm referring to, but the big ones, let's say the New York Times. On the other hand, we have seen OpenAI and many other companies initiating agreements, contracts, so paying money for the past and future use of the big institutions. But that was just one thing that I thought of. As you said, there was a person saying, there's still a lot of content there. So I'm not sure. In your interview, and you will hear it later, dear listener, I recall Seb answering as well. There's not a lot of contents left. So anyway, Seb says AI does not end with scaling. The bitter lesson is over. Because he says industrial applications with domain-specific constraints require new methods and architecture. So in my words, we need the human brain again. So it was a very interesting presentation he did. Are we going to be able to share some of his spoils? I think we're ready, or?
I'm not sure. I asked him because you always have to be a bit careful because it was for the NeurIPS and so on.
All right.
Yeah.
All right. Okay. Well, we're here. I only suggest, as always, dear listener, if you hear something interesting, and even if we don't tell you specifically, we always put a couple of links in the podcast notes. So tell us about the papers you ready.
The papers. Yeah, the papers. So I have to.
How did that work? How does it work? You get into a hall and then
you go into this huge hall. The authors stand next to their papers. You can ask questions, and then there is a discussion.
So they are flip charts, really, right?
Yes, they are flip charts.
There's 4,500 flip charts.
Yeah, it's like AI and Hochreiter.
Yeah, I was going to say, we always request 3 flip charts. We have three major teams,
yeah,
and then we split them by the 3 teams. And as a group of people, we then put our words into the 3 buckets. So there's 4,500. Yeah.
The top 3 topics of the papers were this year: machine vision, NLP, and reinforcement learning. That was interesting.
I saw it as well, yeah. There is a guy, let me see, he's called Jay Alamar. Jay, if you're listening, and he put up an interactive visualization on these 4, what he says 4,500 papers. We'll put that link in as well. And that's very interesting. And it's along the lines of what you said. The words are a little bit different. On the top level, it's always about language models, optimization, innovation, etc., etc. And then if you go down the level, there's, of course, the transformers, vision. So it's along the lines of the topic you say. But it must be kind of, I mean, how can you must be going there, and you must have an idea.
Yeah, before you go to the poster sessions, you need to make a plan what you want to see. Absolutely.
Anything specific that you said? Because, of course, it is all very, very technical stuff.
It's very deep in terms of content, right? Yeah. Too deep for me. Yeah, it's simply research, right? Yeah.
Okay, very good. And I did see reinforcement learning as well, and I was surprised because, again, looking back into 2024, and I look at the major topics that we did in our podcast, reinforcement learning was not there. I do recall that I've mentioned a couple of times, I've been kind of, what's happened to reinforcement learning? We had Jan Kaltnik with us in the Alps this time. Did we have him in the Alps this time? Yeah, we did.
Yes. Yeah.
Yeah, I was
Yeah.
thinking if I was the right one. And Jan was the guy who initiated it. Was one of the big RL guys 5 years ago. So I was also.
And Jan thinks that reinforcement learning is making a comeback. Yeah.
That's what he said at that time as well.
Yeah.
Any other people that you met over there? I think when you went, you said you were kind of, maybe surprised that there was no other representation from the German press.
Yeah, there were no German or European media there. We met people from New York Times, Venture Beat, IEEE, and so on. A lot of US media, but nobody from Europe was there. I think that's a bad sign, really. That's really bad, because this is the most important AI conference in the world, right?
Yeah. Yeah, I think Handelsblatt did do something. And then in the end, we were there, you were there, and we are reporting on it. So that's more than enough.
Yeah.
I do want to give kind of my 2-3 cents on the papers, because I did somewhere write, and it was a post by Varusev Lal. He's an AI research scientist with Intel, live from NeurIPS. Some of the papers from our cognitive AI team on display. Come to the booth, talk to the authors. Now, I wrote, but I deleted it next day because I didn't want to be just a badass kind of. It was nothing like a hate discussion. Nothing had started, but I decided to take it off anyway. Maybe you hear why. Because I say, I'll talk it through very quickly. It's like, I did that once. I really forgot when it was, but I stood there once, maybe 7, 8, 9, 10 years ago, somewhere. I'm not sure where. Very similar in a big hall, not 6,500, maybe only 20 of those. But I really don't get it. If I understand that if you are thousands of people who want to present, they cannot each of them get a 30-minute session, right? But then if you want to catch the people that come by, why do you do that with a font size 5 or 6? I don't understand. Why don't you put up a big word? That's what I would do. I would put up, let's say I am NXAI, I would put up xLSTM, one word. And the people who come by say, what is that? Tell me all about xLSTM. So it doesn't matter in the end. And I felt like such a, Peter knows it better. So I took it off again. Why should I take away the positive feelings of, what did I say, of Varusev and all the other people? So, but that's why it's more better that you tell me. So people do stand around and they do interact with the researchers.
Absolutely. Yeah. Yeah, when you design your poster, it's up to you how you do it. Yeah, there are posters that are very promotional and designed to attract people, and then you have traditional research posters with graphs, etc.
Okay, maybe we move back. Maybe we look a little bit more to what we did this year. And by the way, just as a side note, as you were having fun at NeurIPS, I just happened to see the final game of chess between Gugic and Ding Yuan. I think you heard that there. So I'm not going to make it a big thing, but I do feel, I just saying it, that it was here. There has been for 25 years a huge intertwined link between chess and AI, not to forget. So we have a new world master. So what did we do in 2024? I looked this morning, as I hope you were still getting at least 1 or 2 hours of sleep. I looked back at what we did within our Industry AI podcast. So there's like, let's say 5, 6, 7 big topics. I could ask you which you think are the number 1, 2, 3.
Yeah, my favorite episode is the one with Rainer Brehm. Rainer explains how difficult it is to market Gen AI in the industrial sector. That was an eye-opener for me. And when I'm at conferences like NeurIPS and we are discussing, I always like to refer to the episode. It is all about inference. It's all about how you solve real-world problems. And it's an honest discussion about Gen AI.
That's the word, honest, right? He was very honest. And that's completely unrelated to the fact that Siemens, for 9 months out of 12, was and still is our partner. It is actually the big exception that we take Siemens maybe once in the years. And then we feel completely free. You and I, we discuss our topics that we never, ever discussed them with Siemens. Okay, so that's your personal highlight.
Yep.
I didn't go for a personal one. I looked at what were the topics that we done, and Siemens would be one of the top two topics. Top two. One is, of course, Gen AI, large language models, everything related to that. That's number one. Together with, I grouped them companies. So companies, you already mentioned one was Siemens, but we also talked to Silo. And Silo, they were bought, a month after we talked to them for 650 million. So if you want to be bought, then give Robert and me a call, send us an email, and maybe there's a chance that a month later you're going to be bought for around 650 million. We had Trumpf, we had Bosch, so we had the big Sunfig, Continental, AWS, but I also had, as an example, NXAI, the startups. And those topics were always very broad. Of course, we always talked about Gen AI, but we talked about industrial AI, and we always wanted to know how are they implementing industrial AI, right? So those are number one and two. Then we talked a lot about simulation. That's the number two, I would say here. And then there's a couple of topics that come number three. We did talk about hardware a couple of times. We talked about Copilot a couple of times, in very specific, but also in the coding environment. And we talked about xLSTM, of course, as we do today. That's number three categories. And then we have a couple of other categories that we only did once or twice. We talked about UI design. That was very interesting. Nice topic, actually, that came up, and I'm expecting a lot next year. So that's roughly what we did as far as the podcasts are concerned, right? So
You forgot one episode. The episode with our friend Jakub Tomczak. I met Jakub in Vancouver. He was program chair. The episode was called "Do We Need a Simulink for Gen AI Systems?" Yeah.
Yeah, I did group it into but you're right. I did see him back. You met him, wasn't it wonderful seeing him there together with the other organizers?
Yeah, Jakub was very proud. There's a photo of Jakub Tomczak at a dinner with some of the biggest names in the AI community, LeCun, Welling, and many more. Yeah.
And we're very proud together with you, Jakub. Congratulations to a great NeurIPS 2024.
Absolutely.
Now, what did we do more in 2024? We had a couple of conferences. Our highlight, AI and the Alps, with it.
Yeah.
And which one did we do in addition to that?
AI and the Danube in Linz.
Danube, right. Oh, yeah. I see ourselves at the end of the conference on the little boat floating up and down the river.
Having some beers. Yeah.
Yeah, that was great. That's what I recall. But it was not only that, of course. Very good. And what did we do? We started the year as again, and then maybe slowly moving into the next year. We started with, and that was the first time, Hannover Messe.
Yes.
A conference in Frankfurt.
Yes, we had the conference with 200 participants, and we will be back in January. Tickets are still available. Link is in the show notes, and I'm already looking forward.
It was very nice here, actually. It was very, what should I say? It was a big move from the Hannover Messe, as you know, most of you know, the biggest industrial exhibition conference in Hanover. That is not the Hanover where AI was kind of invented 70 years ago, but it's the Hanover in Germany. In moving to deciding that they're going to have a conference, an industrial AI conference in Frankfurt. Was very nice. And yes, we're going to start off the year 2025 together with Hannover Messe. Then we're going to be doing AI and the Alps. Are we going to be doing other conferences?
We don't yet know exactly where we will be in the fall, but there are already applications.
Okay, very good. So if you want to host one of our conferences in your wonderful town, let us know.
And yeah, at the end, then there was some controversies about the best paper award, more in the show notes. And Jürgen Schmidhuber was also there via social media because he threw in his comments from the sidelines, also more in the show notes. And I spoke to many people at the conference, and their opinion was that he already has a point on some issues. Not everywhere, but on some.
Yeah, I mean, for those who do not know, I mean, Jürgen, how should we put it? Is like seems to be the most honorable person trying to make the history of AI developments correct, right? So he's got this wonderful, not one, a couple of websites where he goes at a very painstakingly detailed explains who in the last, well, I mean, he does go further back to, I guess, to the basics, the Oilers and the whoever they were. But then he really looks in a lot of detail, the modern AI, who invented what. And typically, then he will say that there are certain people, and we're not going to go into that detail, but if that's what you want to know, he will then say, certain people who have received specific awards during maybe even the bigger one from Sweden. What's that called?
Sorry, from Sweden.
The award from Sweden.
Nobel Prize.
That's called Nobel. And he says that, those people, did they deserve it? Did they not? I mean, he's not claiming that, but he says certain people, have not been specific on who were the owners of the shoulders that they built their research on. That's what he's always trying to do, right? And then he has shared his ideas just a couple of days, 2 days before NeurIPS. Yeah. Okay, so interesting that's what you experience locally.
Let's switch to the main part, Peter. What surprised me most, SEP's approach is now faster than flash attention and faster in training too. And it was different at the beginning of the year when they first published the paper in the first architecture. And that is impressive. And SEP will explain how they solved this.
Okay. So, you must have had an amazing attention on the topic of xLSTM and simulation at the same time from XAI. We with SAP, NXAI, everybody around it, but also you, dear listener, a Merry Christmas, Happy New Year for you, Robert, your family. Let's not forget the hard workers in the background, Barbara, Annemarie, Michael and Antje. And of course, to all of you, dear listeners, we welcome you back to our first episode. It's going to be, I believe, January 9th. You're going to be hearing us again. Our editorial plan is already nicely filled up, but then again, there's so many things that come up quickly. You recorded the first episode with Sick, but yeah, and we have so many things written up already, but then so many things will be happening that will bring them also. So looking forward to. Take care and bye-bye.
Thanks, Peter.
Bye-bye, Robert. And have a good sleep later on.
Thanks. Bye-bye.
Welcome to our LinkedIn live stream.
Hello. Good evening, everybody.
Good evening. Good morning. It's very early in the morning for us. We woke up at 5 to organize this LinkedIn live session. We want to talk a little bit about NeurIPS, about the main topics, about xLSTM for sure. And you presented in your keynote 2 days ago, I think, there was a message. The bitter lesson is over for when it comes to AI. What does that mean, Sepp? The bitter lesson is over.
First of all, I have to explain what I mean with a bitter lesson.
Yeah.
The bitter lesson was a statement of Rich Sutton.
2019 or something, yeah.
Yeah, about 2019. And this statement says progress in machine learning was only achieved by scaling up some models.
We saw that in the last years, right?
We saw this in the last year. Scaling up means the models became larger, more parameters, more data was used to train the models, and more compute was used to train the models. Meaning making everything bigger and larger was the key to success. and inventing new methods or having good ideas or innovation did not bring so much performance gain.
So the human was not in focus.
The human was in focus, but only for scaling it up. So human ideas, the cool ideas of the machine learner were not important at this point. But nowadays, with the lesson is over because we enter a new phase. The phase is industrial AI. And for industrial AI, we need these new ideas. We need innovation. We need this
Because we have specific problems, right, in the industry or in different domains, right? When it comes to safety, when it comes to cybersecurity, when it comes to what else?
Yeah, exactly. Especially something like robustness. If you use these methods in a production system, the production process should not stall, should not
24/7,
right? And therefore you have specific constraints. Safety, if the AI works with humans, should not hurt humans. And there are many, many constraints in industry. There are so many requirements if you want to bring something into industrial processes. And here we need new ideas. We need new techniques, new models. And perhaps the models have to become smaller. They have to become more trustworthy. All this stuff will come. And therefore we need again research. We need again some ideas from the community.
But we don't need basic research. Basic research we did the last 50 years, right?
But it could be basic research built on top of this scaled up things. Perhaps you have to have a new idea how to do something, but it's also engineering, how to make it work, how to connect it to a production process or in an embedded system to robots, to drones, to cars, whatever.
You mentioned now smaller models, reliable models, robust models, models on the edge, embedded models. That's the part when an xLSTM comes in, right? You presented a 7B large language model based on xLSTM, but your main focus is not language, or am I wrong?
No, the main focus is not language. We showed that we are good at language. We want to
That we can scale.
That we can scale, and we showed that we have a powerful model, we have a powerful technique, and these days we show it at language. But our goal is to apply it to different domains, especially in domains where inference speed is important. Inference speed means after training, if you apply it, how fast is it? And with xLSTM, we are much faster than the transformer technology. We are much more energy efficient.
That's point, right? Yeah.
We need less compute, and we did it in a shorter time. And this is very, very important, for example, in robotics, in drones, in embedded system like in drones, in self-driving cars where you have also a smaller system, or in automated production systems, PLCs, where you put your system, your AI, in the engine, in the machine you use in production. And here you need two things. You have to be small, and your xLSTM, it has a smaller memory, and you have to be fast. And xLSTM is much faster. It's linear compared to quadratic of the transformer technology. Therefore, it's ideally designed for industrial applications.
And when it comes to transformer, you mentioned it's linear. Can you go a little bit more in details? What is special, maybe to compare to transformers, but also to compare to the, let's call it the traditional LSTM?
Yeah, first, perhaps to transformers. Transformer, if they produce a new item, a new word, or a new data point, they have to look back at all previous data points.
Yes.
And every data point, you have to look back at every previous data point. This comes up to a quadratic in complexity. LSTM and also xLSTM, they have a memory. If you produce a new data item, you only look at the memory. It's a constant memory. Has always the same. All the information from the past is in your memory, and therefore you're so fast because you only interact with the memory, with the stuff you stored, or not with every item. And perhaps you stored very few things, and then you're super fast. xLSTM compared to the original LSTM.
Because there were some limitations, right, when it comes to LSTM.
Exactly. Our idea was to look at the old LSTM and see whether we can scale it up. Can we make it big? Can we make it performant like transformers? And there we identified 3 limitations. First limitation was that the original LSTM could not revise storage decision. If you stored something, you can say, oh no, something more important comes. And this was solved by exponential gating. This exponential gating, you can upweigh as a current item you want to store and downweigh as an item you stored earlier. Therefore, you can be adaptive to the new input. So old LSTM could not do it. Exponential gating, number one. Number two was matrix memory. So old LSTM has only a number as a memory, and now we use a matrix as memory. So matrix is actually a Hopfield network. A Hopfield network, very famous in these days. Right? Exactly, if you think about the Nobel Prize, it's the classic Hopfield network where John got the Nobel Prize, but equipped with LSTM things, equipped with input gate, forget gate, and output gate. It's a combination, a marriage between the Hopfield network, the Hopfield memory, and LSTM. The LSTM cell is now Hopfield memory. And therefore we have much more memory power. We can store much more information.
You wrote a paper, Hopfield is all you need, right?
Yes, Hopfield is all you need. This is Hopfield network is all you need. This was a paper making the connection between attentions and traditional attention and modern Hopfield networks. Okay. But we went back to classical Hopfield networks because they're much more efficient. They're linear and we need as a inference efficiency. Therefore, we resort to this classical Hopfield network, which is much faster because it's linear.
The third limitation?
The third limitation was transformers were parallelizable, but LSTM not. LSTM was slower in training because you could not parallelize training.
Sure.
And by modifying the hidden connections, we could parallelize xLSTM. xLSTM is now as fast as transformer, but
you're faster than flash attention, right?
Yeah, and that's exactly, it's not even as fast as transformer. We could figure out to make it faster. We are faster than flash attention because what we now can do with this recurrent idea is chunks of flash attention. We have a small chunk of flash attention, do the recurrence, another small chunk of flash attention. And if we design the chunks in the right way, we are faster than doing a flash attention over the whole context. If we have chunks of the context as flash attention. Therefore, we are faster than flash attention, which means we are the fastest method on the market. We are the most energy efficient method on the market. And it's both for training we are faster and energy efficient and for inference. Inference was our target. Inference was more important. Inference is if the user uses it and you save energy, but it turned out that we also in training get more energy.
This is new, right? When you first published your paper, xLSTM, I think in spring this year, training was not sure if you're faster, right?
We thought in training we would be slower, but with this idea of these chunks of flash attentions, it turned out that we can be faster because we can use the GPU as a graphical processing unit, as the chips it's running on. We can use it more efficiently. We can design the chunks of flash attention exactly fitted to the GPU.
And that's important, right? You can customize it on the chip of the customer, right?
Exactly. We can customize it on the chip in terms of speeds, but also in terms of memory. We can fix the memory. If we know we have this device or that device, we know there's this memory and we can fix the memory and design everything around this fixed memory size. And that's a huge, huge advantage over other technologies.
Absolutely. And there's also more, right? It's a vision xLSTM, a bio xLSTM. Can you go a little bit more in detail when it comes to the vision xLSTM?
The vision xLSTM is a vision transformer, which became very famous, but instead of transformer, now using an xLSTM. You know, vision transformer, you have these patches in the image and you have a sequence of these patches. You go over the sequence of these patches and then classify what's in the image or whatever you do in vision. And now we use the vision transformer idea, but replace the transformer by an xLSTM. And it turns out that the xLSTM is not only faster. Yes, it's faster, but it's also better in performance. For example, in semantic segmentation, it's better in semantic segmentation, but also in different other disciplines.
And this is important for medical applications, right?
It's important for medical
and industrial applications too.
Yes, but vision has many applications. It could be medical, it could be industrial application. It's like quality control. If you have a piece, make an image, I want to see if the quality is there, but okay, making picture and the thing what's on it. Sure. It's always logistic. It has many application in industry. Computer vision or machine vision was the biggest topic at the NeurIPS this year. That's true. Computer vision is a big topic, especially with these diffusion models. They are very prominent in the conference. The second most prominent topic was language. Yeah, these large language models and stuff.
But let's go on with bio xLSTM. I'm also interested in this bio xLSTM.
Bio xLSTM is
within so Günther.
Yeah. Yes, it was. So research was done by the group of Günther Klambauer at the JKU in the Johannes Kepler University in Linz. And they used the xLSTM for scanning biological sequences. And this could be DNA, proteins, or it could be small molecules, chemicals, which may serve as a medication, which may serve as medicine. And it turned out they were already work with transformers, with state space models, and it turned out xLSTM, which is by far better than others. In one of the experiments where xLSTM was applied to proteins, you have homologous proteins, and you want to see if a new protein belongs to the same family or even generate a new protein. xLSTM was much better. But it turned out the other two methods, the state space models and transformer, can only use context lengths of 36,000, and xLSTM improved up to context lengths 260,000. 260,000 context lengths. It's unbelievable for transformer or for other methods. And it's not only that it can cope with it, it improved, xLSTM improved with more context lengths. And this is astonishing.
Yeah, absolutely. Let's talk a little bit about NeurIPS. What is your opinion on NeurIPS today? What was the main topic? What were the main discussions at the conference?
It's quite diverse. I don't see a clear topic. I couldn't identify. I think it's too many things. Okay, so there were many vision applications, many language applications. Large language models are still very prominent, where you try to analyze the large language models. What can they do? What can they not do? When do they hallucinate? To use them for different applications like planning or whatever. There were a lot of papers or many papers in this area, but I don't see some clear path. It was still that these big models, both in vision and in language, where you have these big models, are applied now to different domains and different tasks, to different applications.
And data was also a very big prominent topic again, right?
Yeah.
I thought this topic is over, but Fei Li said everything depends on data. I think when you train bigger and bigger model, you need more data.
But we don't have more data.
Yeah, exactly.
In language, also in vision, because you scrapped the whole internet and used all the images which some persons put on the internet, and you have the same problem. This text, we already used all text. We run out of data. We run out of data for images. We run out of data for language. And therefore,
open available data.
Yes, open available. But you can start to write new text. Yeah, sure. But it's a very slow process. It takes long. You can start to take pictures. Yeah. But we also have a very slow process. Therefore, it's saturating. And also, using data which is machine produced does not work because it's using the old information and only transforming the old information, and therefore you're focusing on more and more the same things. Yeah, it has a disadvantage. But we know data was important. This was the scaling up phase. It was the major thing in the scaling up phase. Can we get more data? Use larger models with more data. This was the scaling up phase. But now we will enter the industrial phase, where the data is more specific. It's data from one time series, for example, time series, but also images. It's exactly the images of this camera, of this company, or computer languages. Perhaps the computer languages, the code used in this specific company in this specific way. And now we get more specific data, particular data for a particular task, and not this huge general data. This is over, I guess.
Last question, Sepp. LSTM became very famous in the industrial sector when it comes to time series. What about time series and xLSTM? Is there also a connection?
Yeah, of course. xLSTM is a better version of LSTM. Everywhere where LSTM works, I would guess xLSTM works better. Sometimes much better. And there were publications out. There were several publications they applied it to xLSTM, they applied xLSTM, the new LSTM to time series, and they get new state of the art. They improved. And it was one publication after the other. They changed the old LSTM with the new xLSTM and got better results. Okay. And this trend stays, and I'm convinced if you replace LSTM by xLSTM, you get better results. I'm sure of that.
Sepp, thanks a lot. Thank you, everybody, for joining our LinkedIn live stream. We are going now to have a little bit of breakfast.
Yes.
If you have any questions, write us an email, write us a direct message. Looking forward to see you all in Linz. You are invited. Try out xLSTM. It's open source, right?
It's open source. Everybody can use it. Everybody can build a 7B or larger models if you have enough data. Everybody can use it. It's completely open source, completely free. The model, the training code, and the inference code.
Everything, right?
Yes, that's the model. Yeah. So the model, the training, and the inference code, everything is open, and nothing is hidden behind our walls.
And we are looking forward to see your results. Share it. Give us a call. Give us an email, a message, and we are looking forward. Sepp, it was a pleasure. Thank you very much. And now for breakfast.
Yeah, sure. Have a nice day.
Bye-bye.